Okay, so we are in workout problem number 6. And here, I'm not gonna solve again with the homework layout. We will do that in class, and also the solution has it. PDF form has it. But I just want to explain it here, so hopefully you will find this helpful. So there are 4 particles. They form a square, and you can see that each side of the square has a length a, and that's also the distance between most of the charges, but not all of them. And the charges are Q1 is positive, capital Q, Q2 and Q3 are just little q, and Q4 is negative 2Q. Okay, so if you realize something here, they are giving those positives and negatives here, but we don't know if this is positive or negative. Okay, we cannot assume that it would be negative or positive. We will figure it out and you'll see how. Okay, so let's just focus on this statement. So we are looking for the charge ratio if the net electrostatic force on particle 1 is 0. So I want to make sure that the electrostatic force on 1 is 0. And how many forces acting on it? There's going to be forces due to 2 and 3 and 4. So that means there are 3 forces acting on it. Let's show all the forces. So let's start with the free body diagram. So once again, the little q, I don't know the sign, so I don't know if they're going to attract or repel. And free body diagram, I need to know that. I cannot just assume something, so I'm just going to go to the one that I know. So that is negative 2q, that is charge 4. So that is negative, and this is on 1 we have positive q. So what I see is then they are opposite charges, and it's going to the number charge 1, q1, is going to be attracted to q4, and that's going to be along this line, right? So it's going to be towards 4, and you're going to put an arrow right there. So now I'm going to figure out the sign of little q. How am I going to do that? I know that the net force on particle 1 should be 0, right? So if you look at this only force I have, and let's label that F4 or F14, that is the force on 1 due to 4. Look at the components. So it has a positive x component, right, and a negative y component. So I have 2 more forces, and you can see the direction of the forces. 2 is going to be along this direction, and you can see that F14x should be cancelled with that the second charge's force on 1. So you should be able to see that that force is going to be simply to the left. Let's just draw that. It should be that way. So that this is, and this is called F12. This F12 cancels with F14x, x component of F14. I hope it makes sense. And I'm going to do the same thing. F14 has a y component downwards, and the force due to 3 on 1 can be either up or down. It has to be upward because that is the only way I can get rid of the y component of F14, which is downward. Okay, and looking at this now, you can see that F12 and F13, they are repulsive forces. That means Q is positive, little q is positive. Okay, this is how I figured that out. Okay, so hopefully that part is clear. And now we're gonna, again, we're not gonna worry about too much about some unknowns. We're just gonna write our equations. We're gonna be cool with it, okay? So let's start with writing the equations for forces. So F12 in vector form is, since it's to the left, I'm gonna start with negative F12 magnitude, and that's the x-axis, so it's gonna be I hat. F13 only has y component, it is positive, so it is F13, and along j hat direction. F14 is the most complex one. Has positive x-axis, positive x component, right? And we can show this direction, right? And that direction is going to be the y component. And let's just take one of the angles. So it's with the x-axis. What is that angle? Think about that. f(1,4) is pointing towards 4, and that's the diagonal of a square. And that diagonal is going to split the 90 degrees to nice 45 degrees, right? Since it's 45, it doesn't really matter if you use sine or cosine, because cosine and sine 45s are the same. But I'm gonna choose this angle, so I'm writing the x component as, first of all, it's positive because it's to the right, and it's gonna be cosine 45 I hat. And the y component is negative, so I'm going to put a negative sign, and it's going to be f(1,4), and I'm going to use sine 45 because I'm using the 45 with the x-axis. And again, it doesn't really matter for 45 degrees, but let's be consistent, right? So these are the forces, and when I add all of these up, I should get 0, right? The net force on 1 should be 0. And since 0 is a magnitude, I'm going to put that in a magnitude too by putting absolute value. So let's find out what F12, F13, and F14 are from Coulomb's law. Let's write F1. Let's use another color. F12. It's going to be K, Q1, Q2. These are general Q1s and Q2s divided by R12 square. Let's do it better too. Okay, so K, what is Q1? Q1 was given as positive Q. So from absolute value, it comes out as Q. And Q2 is little q. Again, from the absolute value, this is what it becomes. Divided by the distance between 1 and 2 is simply a. This is a square. And F13 is K, Q1, Q3 divided by R13 squared. Again, K, absolute value, it comes out as capital Q. Q3 comes out as Q. 1 and 3, the distance between is a squared, and you can see that these two are the same, right? Magnitude. What about F14? K, Q1, Q4 divided by R14 square. It's going to be K. Q1 comes out as Q. And Q4 was negative 2Q. It's in the absolute value. It comes out as positive 2Q. Divided by, is it a squared? Let's check. The distance between 1 and 4. I want to do this. Oops. This is the distance, right? That's not a, but this is a right triangle. That is going to be a root 2 because it's a squared plus a squared. That becomes 2a squared, and the take to square root, it gives you a root 2. And that's what goes in here, and we're going to square that because that's the distance and the squared, right? And that becomes 2. It will give you another 2 when you take the square of root 2, and those 2's are going to go away, so you have K, Q squared divided by a squared. Can you see that? I hope you can. This goes with this because this is going to be squared, okay? These, they cancel out. So, okay, so let's write down our equation now. F1 equals to, that's the net force, okay? Net force is all those added in vector form, of course. The equations I got are just the magnitudes, but we wrote the vector forms up here, so we're going to use them. F12 was negative, so we have negative K, Q, Q, a square, and that is negative I hat direction, plus F13 is along J direction and it's positive J, so it's positive K, Q, little q divided by a square, and that's J hat. And now I'm going to write F14, and it was positive x-axis, and it is kq squared over a squared. So I'm really using this equation here, cosine 45 and sine 45. Cosine 45 is root 2 over 2. Okay, so I'm just gonna do that. It's just gonna help me. You can find the number from the calculator, that is fine too. So this is my cosine 45, it is root 2 over 2. And that is I hat direction. And we are going to write also the j hat, and that was negative because it was pointing down. So it's the magnitude of F14, k capital Q square divided by a square. I'm just using this as you realize. And sine 45 is the same, root 2 over 2. And this is j hat direction, it was negative. Okay. And we're saying that net force is 0, so this whole thing is 0. Okay. So what we need to do here is let's combine I hats together and j hats together. And since the other side is 0, those I hats should add up to 0, and those j hats should add up to 0. So what I mean by this, so if I look at the x component, that should give you 0. Negative k q little q a squared. I'm taking the first term here. And this second term, which is I hat again, plus k q squared over a squared root 2 over 2. That's equal to 0. X component is 0 because there's no net force. That means there's no x component either. Same thing, we will do it for y component. The first one is positive k capital Q little q divided by a squared. And also realize that I'm dropping I hats and j hats because I don't need them anymore. I'm just matching them, and on the right side is 0, so there's nothing to match, so that's why I'm putting on the right side as 0. Next is negative k q squared over a squared root 2 over 2, and that's going to be equal to 0. Okay, and let's recall what we were trying to find. I mean, we did a lot of algebra here. We are trying to find this ratio little q divided by capital Q. And you can use one of these, and you can see that they are going to give you the same thing anyway, and as they should. My A here looks like a D. It's not a D. It's a A. So it doesn't matter which one you use, but you don't really need both of them. Okay, so let's just choose this and then make it equal to each other. So what we have is then k q squared. I'm taking this on the other side and then switching the sides. K q squared over a squared equals to k q squared over a squared root 2 over 2. Okay, q squares go away, a squares go away, k's go away. Oh, I was like, nothing is left, but the equation doesn't make sense because we messed up here. There's a little q here, that's the first term right here, right? So one of the let me fix this part too. One of the q squares are going to go with the capital Q here. And then what we are having is q equals to q root 2 over 2, or q over q is root 2 over 2. But we need to check one more thing. Since I got rid of all the absolute values, maybe this wasn't a good idea. Maybe we should really carry out all the absolute values. This was an absolute value, okay? So this ratio looks like it's positive, but it could be negative. So I'm just gonna check from my relations here. So this was the case. Q1 has a charge positive Q, right? And this was also positive. So for this problem, the answer is going to be positive because both Q's are positive. But this is not always true. So here, these are the same. If I get rid of the absolute values, I'm gonna kind of emphasize emphasize that I thought about the sign and they were both positive, so the ratio is going to give me positive. This is very important. If you don't think this last step, while the plus problems might be an issue because you're not going to get the right answer. Sometimes they're negative and it's so easy to miss. Okay, so you got to think about it at the end one more time when you find charge ratios. Don't forget that.